Hi, I'm Anindo and I'm back again with exercise 9, activity 2. This one is on debugging. I understand that debugging is not the most favorite part of programming for any of us, but it's an integral part and so to speak, it's part of life. And so let's just get down to the business and do it best that we have to do. So this problem talks about a ball bouncing around in this box, two-dimensional box, and we provide its dimensions. We give the loss coefficient, and we know the velocity changes. The perpendicular component of the velocity changes. Apart from that, it travels in straight lines. So, and it gives the contact points, and I have made a copy of the program and I'm going to uh, make changes in that. So it's a good idea to save a copy because you never know what can happen to the original one, and it's very tempting when you get hold of a program to try to run it. So let's start that way. And first we provide the number of bounces, let's say 5. Let's keep the dimensions simple. uh, it's a square, and then the loss coefficient to begin with, let's choose 1, so there is no loss. And if we try to run this, we see the first issue, which MATLAB tells us it's at a certain place. It's at line 16. So you go back there, and when we look carefully, we notice that although we don't know much about the program at this point, that this position 1, then you have this random number. It's a 2 by 1 matrix, and remember the message that we got, it's about matrix dimensions must agree, so something going on about dimensions. And we see that this width and height, this looks like it's a 1 by 2 matrix, that is 1 row and 2 columns, and we are trying to multiply a 2 by 1 matrix, and more importantly we are trying to do an array multiplication and not a matrix multiplication. So something is wrong here, and what we understand is that we want to find some initial random positions, and just 2 positions. Here you have 2 random numbers, 2 by 1 vector, so this must be a 2 by 1 vector as well, and that means we are missing a semicolon here, and that would probably solve it. So we save it, we go back, run it again, and we see that that error is gone. So now it's something about the variable y wall. So let's go there. It's in line 69. So if we click on that, we come to line 69, and we see there is something called y wall. But I think at this point you get the idea that how addictive it is to try to debug it that way without even looking very carefully at the program. But it's important that you understand the program, especially so if it is not written by you. So let's take a quick look at the program at this point. So we see that we first have the position matrix, and since there are n bounces, and then we also need the initial position, so we have n plus 1 points in this position matrix. And by the way, you also understand at this point how important it is to write detailed comments if there are other people who are trying to read your programs, or if you're trying to read someone else's program. Then these comments are the only or the main mode of communication, and we should not ignore that. And also, if you write your own program and don't take a look at it for 6 months, then once you come back, these comments are going to save your life, at least many hours. And we once we have the positions, we assign a random direction. Then we have this function which would take in all these parameters and would give us the new position. So finally we plot the positions. Then this is the function which is the core of this program, it seems, and it has these parameters it takes in this function called newpos. And then we have, if we read through these comments, I'm sort of going to rush through it, but essentially we are trying to find first which wall it's going to hit. If you look at it, there are two walls parallel to each of x-axis and y-axis. So it seems that first we are trying to determine whether the ball is going to hit in any of the x wall uh, that the program uh, mentions, which is it's 0 and w, and if you look carefully, it's the walls parallel to the y-axis. That could also be obvious from this 0 and w. W is the width, and then you go down and you see this coordinate geometry formula where you can find the coordinate of the straight line if you give the slope, which comes in the form of direction 2 over direction 1. And at this point it's a good idea to sit down and check that this formulae are correct, because otherwise, even if it calculates something, you might be getting wrong results. So then you go down and you see that there are the same thing going on for the y walls, and then you see that at the end you have this error statement, unable to find intersection, and that essentially says that if you did not find intersection with any of the walls parallel to x-axis or with the walls parallel to the y-axis, then there is some problem, because this ball has to stay within this box. So with this, we go back and we see that we had this error about y wall in line 69. So we go to line 69 and we see there is a y wall, and we it says undefined function or variable y wall. So that's interesting, and one thing to use is a search criteria, find and replace criteria, or search criteria, search feature of the editor that you are using. And we can do it here through this, and let's say we search for y wall, and the other one instance we have is here, and it stays here. So that's probably kind of the sign of a trouble, because y wall should be defined somewhere else. And we see that if we look here, x wall appears here, x wall appears here, but x wall is also defined here. So here you see this x wall is there again, which is probably a typographical mistake. So most likely these should be y walls, and maybe that will solve it. Let's see. Alright, so that error went away, but we have something new right now. It's about again matrix dimensions not agreeing somewhere, line 73. So if you go to line 73, we see this next direction. So that's the this direction vector, and then it finds the next direction. So that should also be 2 by 1 matrix, and we can see 1 and loss minus loss, which is multiplying this velocity with the loss coefficient. That's a 2 by 1 matrix, and we know that this direction, that was also 2 by 1 matrix. So if we look at it carefully, we see that it's given as matrix multiplication, whereas what we're looking for is array multiplication. So this dot is missing, and that's kind of a simple thing to miss in MATLAB. So let's see, we see that there is another instance of that here, so we fix that too. So let's try to go back and see what happens. Oh, it printed, something came, and we might feel that okay, so now it's alright, and let's try some extreme examples to see whether it's actually working alright. So let's reduce the loss coefficient, and we see that also seems to be working. So just to have fun, we also increase the number of bounces to something crazy, and we see that we have gone to that dreaded section of the program which says we have not found any intersection. So that's that's strange, but that's also part of programming. When you feel that you are done and the program is working, you hit this wall, and or you don't hit the wall. So these kind of problems are often very hard to detect, because you see that the program is running for most of the values maybe, and it's probably a logical error, and it's very difficult where actually that has crept in. So at that point, it's a good idea to go through your program very carefully and see if all the logic that you are using to calculate something, they actually make sense. And if you do that here, but before you do that, you still need some kind of guidelines. And the first thing that I use, or most people use, is to print out some statements, check some values, and see if there are any obvious ones which are standing out, because they're abnormal, they're too big, they're too small, they're imaginary, they're negative. So when they shouldn't be, I mean, so I think the first thing I would do, maybe I would try to print out this next pause, this statements, because if it is going to this error part, most likely it's not going into any of uh, these statements, if else conditions, because it's not hitting any of the walls. So before that, it's trying to calculate this next pause statement. So let's print that out and see what happens. So we could have just omitted these semicolons, but then that would print out just next pause, whereas we want to see not just next pause, we also want to see what the directions are and what maybe the positions are. So we do the same thing with here. Oops. And let's save it, run it again, and we hit that same mistake. So now if we go back to the to this, we see that positions look alright, except one of them is at 1, which is like the boundary, but that's still okay. But if you look at the direction, that looks funny, because that looks extremely small. This value does not make sense. So this is direction is a 2 by 1 matrix, and when it's multiplied by this number, it means this number is multiplying uh, both these numbers, and this number is ridiculously small. So it's essentially this is 0, and that's probably not something that we physically expect. So this is the point where we go back to the program and you look carefully into it, and you see that there is a small complication that's really easy to overlook here. So you see that first we assign directions, and then when we're talking about changing velocities, we don't have a separate velocity array. We are working with the direction array, and we are multiplying the direction with the loss coefficient, so either the x component or the y component, depending on which wall the ball is which wall the ball hits. But you see that velocity is going to go down constantly, because we are multiplying with this number less than 1 constantly for each bounce. On the other hand, if we are talking about, so that means velocity is supposed to go down, but the direction doesn't have to tend to 0. So that means even if the velocity goes down, if you want the direction, we have to, you can imagine it's the v cos theta and v sin theta. So we have to first normalize these numbers, these individual components, to find the direction. So that means once we have this next direction, next dir, we should normalize that. And the way to do would be dividing this by uh, oops, so by the square root of sum of next dir square. So that would find the individual, the squads, the individual components, sum them up, take the square root, and that's the norm. So in fact there is a cool program, cool function, which would do the same thing for us, and that's just the norm of this. So let's copy the same thing, let's put it here as well, and let's comment this out. Oops. And while we are at it, let's do the same thing with the direction vector, although it doesn't matter so much here because this comes up only once and that would be probably fine. And let's see what we get from here. So now we see that apparently all the problems are gone, and we do see some nice bounces for all these numbers that are there, and that probably shows that we have finally figured out all the problems it had. So for this program that is the case, but there is something else that I would like you to see. You can also use the debugging feature of MATLAB. So for example, you can let's comment out this. So that we can regenerate the problems. Oops. And then we have this breakpoints that we can introduce for let's say this is where we wanted our breakpoints to be, and we can introduce breakpoints here and also here. And now if we try to run the program, you will see that the program automatically brings us to the point where it stops, and this is where it stopped. And not just that, if we go back to the workspace, we see that it also prints the values for all different numbers there, all different parameters and variables. So by setting breakpoints, you can come back to that part of the program, and in the workspace you would get the values of different variables. Also, you have to keep in mind that wherever you are starting with a program which starts with random number generators, then each time you hit enter, it's probably going to start afresh, and that's probably not what you want. So you might even need to set some initial values and stick to that and work through the program and see what's not working. You can also choose to have breakpoints at which stops on errors instead of stopping each time in different lines, the way we set it up. So you have to play with these features, and eventually you'll find some some combination of things that work for you and help you to debug your programs. So that would be all for today. I hope this would help you in your programming efforts, and I'll see you in some other exercise later. Bye bye.